Hello everyone. Today we are going to discuss the last topic of this chapter of linear equations in two variables, and today's topic is called equations of lines parallel to the x-axis and y-axis. So today we are going to discuss in this video about those equations whose geometrical representations are lines which are parallel to either the x-axis or the y-axis. So those equations we are going to discuss in this video. So let us begin with an example. So the first example says, give the geometric representation of x minus 2 equals to 0 as an equation in one variable and in two variables. So let us see how to represent this equation in one variable as well as in two variables. So first of all, we will represent it in terms of one variable. So what to do here? First of all, we'll write this equation and try to find out the solution of this equation. Now since it is in one variable, it is well known from the given equation that only one variable is used here, that is x. So we'll solve for x. So that will give us x is equal to 2. Clear? Now we have to represent this x equals to 2. Where will you represent? On the Cartesian plane? Yes, on the number line. Because x equals to 2, here only one variable is represented, or you can say denoted. That's why we will represent it on the number line. If it was two variable, then we would have represented it on the Cartesian plane by plotting the x and the y axis. But since it is only one variable, so we'll denote it or plot it on the number line. So it will look like this. So then after drawing the number line, we have to denote where is x equals to 2 and there is x equals to 2. Clear? Now we have to denote it, or we have to find out the geometric representation of the same equation in two variables. So how to do that? First of all, we will write the given equation in the form of linear equation in two variables, that is ax plus by plus c equals to 0 form. So if we write it in that form, our equation becomes x plus 0 into y minus 2 is equal to 0. Clear? Then we have to put some values of x and y so that we can plot them on the Cartesian coordinate, or in the Cartesian plane, that is in our graph. So here whatever value of y we put, it will be ultimately equal to 0, because 0 into y is 0, and the value of x will remain constant, because already we have found that x minus 2 equals to 0 and x is equal to 2. So x value will remain constant. Other than that, any value of y we can put. So here we have put these all values, that is x equals to 2, y equals to minus 1, x equals to 2, y equals to 0, x equals to 2, y equals to 1, x equals to 2, y equals to 2, x equals to 2, y equals to 3, and so on. As we know, there are infinitely many solutions, so we can go on writing. Just one thing that will remain fixed is here, that is x value, because x must satisfy the equation x minus 2 equals to 0. So it will remain as it is, and y value can be anything. All the values of y are permissible here. Clear? So let us see how the graph will look like if we plot these points. So the geometrical representation of the equation will be looking something like this. So here you can see it is after plotting all the points, that is 2 comma minus 1, 2 comma 0, 2 comma 1, 2 comma 2, 2 comma 3, we will get a line which is parallel to the y-axis. Can you see it? Yes. So it is a line which is parallel to the y-axis. So we can say that the graph is a line parallel to the y-axis and situated at a distance of 2 units to the left of it. So from the left, the y-axis is on the left side, as you can see in the figure, and it is that line, the required line that we got, or the line of the equation we got, is situated at a distance of 2 units and it is parallel to that y-axis. Clear? Now moving on to our next question. Now here we have to solve the equation is given to us, and represent the solution in one variable as well as in two variable. So sometimes the question may come written as in terms of one variable and two variable, or sometimes it may come in this way. You have to represent it in number line or represent it in Cartesian plane. So it is well understood, if it is a number line then one variable, if it is a Cartesian plane then it is two variable. Clear? So let us do it, same process like the earlier one. So we have to solve for x here. If we have to find for one variable, or if you have to plot it on the number line, we have to solve for x or solve for y, whichever variable is given to us. So here x variable is given to us, so we'll solve for x. Now if you solve for x, we get x is equal to -4. So this is a required value of x that we get. Now we have to plot this x equals to -4 on the number line. Since it is only one variable involved here, so it will be represented on the number line. So it will look like this. So on the number line, as you can see, 4 is on the left side of the number line, -4. So it is on the left side of the number line. So this way we can represent the equation in one variable, in terms of one variable, that is on the number line. Now if we have to represent it in terms of two variables, that is on the Cartesian plane, then how to do that? So similar process. Here the value of x will remain constant because it has to satisfy the given equation, whereas the different values of y are permissible here, because if we write it in the linear equation in two variables form, that is ax plus by plus c equals to 0 form, then the equation will look like this: x plus 0 into y is equal to -4, or we could have written plus 4 equals to 0 also, we could have written. So it is same thing. So if we write it in this form, then it is a linear equation in two variables, and as we know that all the values of y will be permissible here, because whatever we multiply with y, ultimately the result will be 0, because 0 into anything is 0, and x will have that same value, that is x equals to -4, because it has to satisfy the given equation. Clear? Any other value of x will not satisfy the given equation. So then we can easily find out the different solutions of this equation. So the different solutions, we have found out two solutions here. One is x equals to -4 and y equals to 0, and x equals to -4 and y equals to 2. So you can find out other many solutions if you want. I have found out here only two solutions, because two solutions is enough to draw a line. So that's why only two solutions have been found here. And the graph will look like something like this. So it is also similar to the earlier one. Only thing is that it is onto the right hand side. You can see the y-axis is on the right hand side of the given equation, or the line which represents the given equation. So here, as you can see, what is called, we have plotted -4, 0 and -4, 2. There are other coordinates also which can be plotted on the given line of the equation. So what did we find here in inference? That the graph is a line which is parallel to the y-axis and is at a distance of 4 units to the left of it. Yes, it is 4 units, or we can say that the y-axis is 4 units to the right of the line of the given equation. Clear? But you can see that it is parallel to the y-axis. Similarly, if the variable y is involved there, here only the variable x is involved. If, say, in the given equation the variable y is involved, then you would have seen that the line would have been horizontal and it would have been parallel to the y-axis. Since here in both the problems we have seen today that the variable that has been involved was x, so it was parallel to the y-axis. Now if the variable would have been y, then it would have been parallel to the x-axis, and the line would have been horizontal, not vertical like this. So I hope it is clear to you how to plot the graphs of those equations which are parallel to the x-axis or the y-axis. So this brings us to the end of this video, as well as this brings us to the end of this chapter. So you can try other examples that are given in the book. So that's it then for today. Thank you and have a nice day.